right, so you have your notes. We're going to go over a definition for domain, range, vertical line, and horizontal line tests, which we've already said a little bit about. The set of all input values that produce an output. Output is also the y value. In other words, the values of x for which the function is defined. We said included yesterday. Which values of x are included? Okay, range, the set of all possible output values, which would be included y values. Included means equal to. Okay, read the vertical line test box and see how many of those blanks you can fill in. Okay, volunteer, who can fill in some of those? Daniel?
Determines if a relation is a function.
Mm-hmm.
And a graph in the coordinate plane represents a function if and only if no vertical line intersects the graph twice, or more than once.
Yeah, I'm going to say that.
Okay.
No more than once, because technically it could intersect 3 times. It's just a weird looking graph. No more than once. Okay. I'm going to fill in these first 2 blanks because this is a new vocab word. Determines if a function is 1-to-1. Notice that we're already a function, so we've already passed the vertical line test. Is 1-to-1. Sometimes you see this written 1-1. Okay, means in order to be 1-to-1 from the homework, first you pass the vertical line test, then you pass the horizontal line test in that order. Means 1x, 1y. Exactly, no more. Okay. A graph in the coordinate plane is 1-to-1 if and only if no horizontal line intersects the graph no more than once. All right. Increase, decrease, or constant. Here's where we're going to start color coding a little bit. Increasing when rises to the right. And I'm going to say that this is a positive slope. Okay. And this is where we're going to highlight or write in pencil or pen or colored pencils. They're up front if you need to borrow. Okay, I'm going to go yellow. I'm going to make mine yellow. You make it whatever color you want. I'm going to do mine yellow. There should be a little box of highlighters up here and colored pencils so you can borrow. Okay, and I'm going to highlight the portion of this picture that appears to have a positive slope. Would anyone care to describe to me where that's happening? Any way you want. Tell me where to start highlighting. Tell me where to stop highlighting. Lucas? Okay, you said -2004. So from that point to the next one? Okay. Yeah, not finished. Keep going. Who else can? There's more. Drew.
From -4, -2 up to -0.
Yes. Okay. Anywhere else? Looks fine. Good. Okay. So let's go decreasing. When the graph falls to the right, and so this is going to be a negative slope. I'm going to make this one green. Okay. Now I want to highlight my negative slopes. Somebody new, tell me where to highlight. John?
-6, 0 to -4, -2.
Okay, and then Alyssa.
3, 4 to 6, 1.
Yes. All right. And constant when at a... I know that's bad form to reuse the word in the definition. Okay? So that's why we're going to have a secondary description. 0 slope. Who can describe to me where to highlight without naming the whole coordinate? Right, so far everybody's given me the coordinates to start and stop at. Who can describe where without giving me the whole coordinate? Rafid? Yes, okay, where y equals 4. True. Who can give me another description?
Where there is no slope.
No slope makes me think undefined, which would be a vertical line. So yeah, 0 slope. I got you. But I want to know, where should I highlight? How do you describe to me where to highlight? That's the whole point of the lesson, is how do I describe where the different characteristics are happening? That's what you're learning. And whatever you say, I have to know exactly where you're talking about. I mean, you're like, right there, right here. But how are you going to describe to me using words where to highlight? Yes? Plateaus, yes. But let's say I don't know what plateau means.
The only straight line.
Straight line. Straight could be like this too, though. Horizontal line, yes. What about if I said, begin highlighting where x equals 0 and stop highlighting where x equals 3?
You could do it on the x-axis.
Okay. On the given graph, okay, let's label the graph, f of x, which would be the lines that we have drawn here, okay? Highlight on the graph where x equals 3 to where x equals, or x equals 0 to where x equals 3. Okay, Daniel, what?
Oh, highlight the portions that are not. That's not highlighted.
Okay, yeah, that's fine. What if I said, give me the domain? What if I said, give me the domain of the graph 0 to 3? That's it. Why do you do domain first? Because you have to have a way to describe where the characteristic is happening. All right, see that? Using the graph called f of x, answer the questions. Where is it constant? Where is it increasing? We've already highlighted the portions of the graph. Now you describe the domain that corresponds to it. Domain is exactly 1x. Means we will all be talking about the exact same place on the graph. Okay. Somebody who didn't describe the highlighting to me, give me the domain of the yellow portion. Laura.
-4 to 0.
Yes. And I'm going to go open. It's actually preference, guys. It's 50-50 on textbooks. You pick up half of them, they'll do this open. You pick up the other half, they'll do it closed. I won't take off, but I'm just going to do mine open, and I'll explain to you why. Okay. Domain of the green portion. Somebody new. You keep track of who has or hasn't answered. Gabe?
We're at -6, -4, union 3, 6.
Yes, very nice. And now, because we all understand how to read domain, we know exactly which portion of the graph you're referring to. All right. Constant. Do you have it, Dean? Yeah?
3.
Yes, 0 to 3. Okay. So in my particular case, when I'm doing my intervals of increase, decrease, and constant, I'm always going to use open, not closed. That is my preference. It is correct either way. Okay, which would be the soft open parentheses, not the equal tos. And that is a preference. I won't take off for it. All right, so we're going to do a function is continuous over an interval of its domain if you can draw the graph over that interval without lifting your pencil. All right. So we're going to look at all 4 of these graphs, and we're going to decide whether they are continuous or not. And I'm going to do it by tracing the graph, just to see if I have to lift my pencil. So I'm going to start over here. And do I lift my pencil to draw it? No. So that means yes. Okay. Are these continuous? This one is yes. Okay, let's do the next one. Don't get too creative. See that open circle there? I skipped over it. So that's what you have in this graph. It's a little small. Do I draw the graph without lifting my pencil? No. Okay, so we're going to put a reason. No, the graph is not continuous because missing point, right? There's a point that is missing. It's called a point discontinuity. Okay, so now I'm going to do the next one. Okay, this one looks pretty clear. I start on the left side, I trace it, and then I skip up to the next section and I trace it. And I did lift my pencil. But how do I describe the difference between this and this? Because I lifted my pencil both times, but those pictures are clearly different. So not continuous because there's a jump. Now that could be a jump in x coordinates or a jump in y coordinates. In this particular case, it was a jump in the y coordinates, but I'm not going to be specific on which one. It's the y values that skip from 0 to some positive number here. It's a jump. Okay, and then this next one, you may or may not have been introduced to this vocab before, but I do pick my pencil up and I skip over to this second section here. But if I look really closely, there seems to be this vertical line that separates the two sections. And so it is not continuous, and it's because of an asymptote. The P is silent, but I say it to spell it. So asymptote. Okay? So if I go back and look at the definition to the left, there are no missing points. There are no jumps or asymptotes. These are the only three types of things that make a graph not continuous. So far, you've only dealt with continuous graphs, lines, maybe parabolas. As we move through the year, we will end up with jumps, holes or missing points, and asymptotes. We will go through all three of those types of graphs before we're done with this year. Okay. Turn it over. And let's take, I don't know, about 90 seconds. See if you can fill out the x and the y-intercept box. Okay, who can give me possible answer to the x-intercept box? Just the two people who've already answered a question today. You've already answered one too. Come on, you can do it. Any blank you want between those two boxes. Okay.
I'll do the identify the x-intercepts and the f-vects.
Yeah, go for it.
-1, 0.
Yep. Keep going.
And 3, 0.
And?
And 5, 0.
Yes. Okay. See, not so bad. Okay. So the x-intercepts are the zeros. We had a discussion on whether or not you're supposed to put an E in there. Right? ES instead of just S. Word takes it either way, so I don't know. Now that I'm thinking about it, I can't decide. I don't know which it is. So there you go, zeros. Okay. They occur when? There's two ways to say this. When f of x equals 0, or when y equals 0, or when you touch the x-axis, right? When you're on the x-axis. All right. Next box, y-intercept. Okay. Volunteers. Any box, doesn't matter. Yeah.
For the y-intercept on f of x, it's at 0, -3.
Yep, 0, -3. All right, so you can find the points, but you got to be able to describe them also. Not quite. I understand you're trying to say the same value as like the y coordinate, which is accurate, but there's a different word we're looking for there, which I'll fill it in. The constant term. It is the f of x and y are the same. I agree with that. But when you did linear equations and you said mx plus b, that's the constant term. Right? It's the last number in that equation. The b value is the y-intercept. Well, it stays the same. We're going to increase our degree this year. We're going to do quadratics and cubics and quartics. That last number, it's still the y-intercept even when we change the equation. Okay? The y-intercept occurs at x equals 0? Occurs at what x coordinate? And we're going to say on the y-axis. Right? Everybody can kind of pick the point out, but then you got to describe it. Okay, here comes the next set of highlighting. So I'm going to walk you through this one. Graphically, f of x equals 0 when, okay, let's pick a color. Sure. Pink. Why not? All right. Where is f of x equal to 0? On the, no. Yes. On the zeros, yes. So I'm going to make them pink right here. You want to go up here and highlight this because it's the same thing. F of x equal to 0. See the function notation? You got to be able to read it. Okay, so can someone give me a word that would describe where those 3 dots occur compared to the x-axis? Yeah? No? Yeah, on the x-axis. On the x-axis. All right. Next, let's do this one. Okay, f of x is greater than 0. Well, f of x is y. Where y is greater than 0. I'm going to put something about the quadrants on this graph, and that might help you answer this. This is quadrant 1, and this is the plus plus quadrant. This is quadrant 2. This is the minus plus quadrant. This one is 3. This is the minus minus. This one is 4. And this one is the plus minus. And those are for the x and the y coordinates. Okay. What is yellow asking us about? Can someone read that to me without saying f of x? What would you say instead of f of x? Y. Okay. Graphically, when is y greater than 0? One and 2. Quadrants 1 and 2. Where do you plot positive y coordinates? Quadrants 1 and 2. Highlight the portion of the graph that corresponds to quadrants 1 and 2. Function notation. You gotta be careful about, is it asking for about y coordinates? Is it asking about x coordinates? Y greater than 0. Now I need a vocab word. Visually describe where that is happening compared to the x-axis. Yeah, above. Okay. Now, lines 2 and 3 are very similar. They're combining some information there. So, when f of x is greater than or equal to 0 when f is on or above. So that would be pink and yellow. Pink and yellow is the answer for that. All right, let's do green. Graphically, when is f of x less than 0? So that is the same as asking about when the y values are less than 0, which puts me in quadrants 3 and 4. So now you got to go and you got to highlight the sections of the graph that are in the correct quadrants. Notice how I picked my pencil up, right? There's 2 sections that are both answers. And let's go with below, right? Below the x-axis. Okay. Now, all right, lines 4 and 5, combination. So, on or below. All right. We have color-coded the graph. That was the hard part. The easy part. Can you give me the domain that has already been color-coded? Okay. For what values of x, I'm asking you to give me the x values. That would be the domain. That corresponds to f of x greater than 0. So in this particular case, f of x greater than 0 corresponds to yellow. What is the domain of the yellow portion of the graph? It's a multi-step process. I color-coded it, and then I'm going back to look at the domain that corresponds. All right, brave new person. You can pick any one of those lines to answer. 1, 2, 3, or 4. Don't make me start like tallying who answers questions. Have you answered once? All right, Dean, you can give it a try.
For 1, it's -1 to infinity of parentheses.
Super close. Continue giving me the answer before I write. What else do you want to say? There's two portions.
Oh, right. It is 3 to
Yeah, okay, so I'm going to put union. You made a very small mistake in the way that you said the first one. Okay? Super small. So we'll compare when we get the right answer. Anyone know what goes here? Colin? Yeah, okay, so Dean said -1 to positive infinity, but that would be y. That's like a mix of x and y coordinates. The x coordinates are negative in quadrant 3, and because this is domain or x values, we just got to be careful with those arrows. It's really tricky when they're mismatched, okay? That's the hard part. You're looking at y values, but you're writing down x's. There's a lot of steps to this. Okay, so let's do the next one. Who can tell me how to change my answer for number 2? Because they're almost the same question. Move it up. Okay, Anne.
It would be open bracket -1 to 3.
Oh, no, that's okay. Oh, no, that's fine. All right, go for it. Yeah.
Sorry. 2, 3 open bracket, union open bracket 5 to infinity open bracket.
Yes. Okay. Yes. How do I do number 2? Where's your name tag? Is that yours? Okay, Laura.
Close. I mean, you'd write the same thing, and then you'd write a close bracket.
Where?
Between the union.
What do I do with the 5? Do I leave it open or close it?
Or close it.
Close it. Yeah, because I'm touching all of those x-intercepts would all be included, would give you the hard bracket. Okay.
Is that why we use open?
Yeah, because here, not equal means not including the part that is touching. Yes. Keep right. We've got a lot of different domain and range. That's open and closed for its own reasons. Increase, decrease. Doesn't matter. On, above, could be included or not included depending upon what it's asking. So there's a lot of different rules to remember for each characteristic on whether you use open or closed brackets or parentheses. Okay, how do I change number 4? Yes?
Close bracket, -1, 3 close bracket.
Mm-hmm.
Union, close bracket 5, infinity open.
Mm-hmm. All right. Almost there. Next box. We kind of already have this one labeled on our graph. End behavior is talking about the arrows. I see 2 arrows on my graph. Right, there's 1 arrow here in quadrant 2 and 1 arrow here in quadrant 4. End behavior is asking about x approaching positive infinity. That's the very most positive value of x you can ever get. That would be the right side of the number line. That's quadrants 1 or 4, right? Positive x's. Okay? Or negative infinity. Well, negative infinity is the very left side of the number line. And in this particular case, that's negative x's. That's quadrants 2 and 3. So now I need to answer the statement. As x, the arrow, like tells you to look at the arrow, approaches negative infinity. That means as I look to the left side of the graph, f of x, that's y. Where is y pointing? Up. It's pointing up. It's a negative plus. It's asking about the coordinates of the arrow, which is infinity because it's an arrow. It keeps going. So if the x coordinate of the arrow is positive infinity, what is the coordinate of the y portion? Yeah. So it's new notation, right? I just walked you through and read the notation to you. So you're like, that seems quite simple. But you have to remember what that notation is asking you. That's the part that gets hard. If I say the sentence and I read it, it makes a lot of sense. But you have to remember how to read it to yourself. Okay. Last box. Maximum, maximum, minimum, minimum. These are actually turning points. Okay. Turning points is where the graph changes. Increase, decrease. Or decrease, increase. It's where the increasing and decreasing changes. That's why we do that characteristic first. So as I look at my graph, it appears as though I have 4 turning points. Right there. Do you see how the graph changes directions from like moving down to moving up? Because you read left to right. You read your graph left to right. Don't look at the arrows. Just look at the graph. That appears to be a negative slope. That means decrease. That means increase. And it's a low point. That means it's a minimum. So let's figure out, that would be line 3. Relative minimum is positive 1 at where does it happen? It happens at 1, 2, 3, 4, negative 4. It's really just the coordinates. The minimum value is 1, but it occurs at x equals negative 4. Right, you have 3 more. Fill them out. Okay. Volunteer. Any one of the 3 lines remaining you can pick. I know you've answered. Have you answered? A little bit. Okay, Emery.
For the first one, relative maximum of 4 at -2.
Yes. You've answered 1. Okay, go for it, Laura.
For the last one, 4 at 2, or -4 at, wait, negative, well,
Mm.
magnified.
Yeah, at.
Wait, I'm confused, sorry.
Where does it happen? Oh, okay. Colin.
For number 2, the relative maximum is 2 at 4.
Mm-hmm. Yes. Lily.
For the last one, I think it would be -5 at x equals 1.
Yes. There you go. All right, guys. Nice job. Whew.